Welcome to World of Pharmacology. Today we are going to discuss on the topic Pharmacodynamics. Please do share, like, comment and subscribe. In simple terms, pharmacodynamics means what the drug does to the body. So it is a study of drug effects which includes the action of drug as well as their mechanism. Modification of the action of one drug by another drug is also included in pharmacodynamics. Next, let us see what is the principles of drug action or types of drug action. That is, how these drugs produces their effect. Drugs may produce their effects through stimulation, depression, through irritation, through replacement or cytotoxic action. Let us see them one by one. First one is through stimulation. It is the selective enhancement of the level of activity of specialized cells. For example, adrenaline can stimulate the heart. Pilocarpine stimulates salivary glands. However, excessive stimulation is often followed by depression of that function. Example for that is high dose of picrotoxic, which is a CNS stimulant. It produces convulsions followed by coma and respiratory depression. Next one is through depression. It is the selective diminution or decreasing of the activity of specialized cells. Example for that is barbiturate depress CNS. Quinidine depress heart. Certain drugs stimulates one type of cells but depresses the other. For example, acetylcholine stimulates intestinal smooth muscles but they depresses SA node of the heart. So it's not possible to simply classify drugs as stimulants or depressants. Next drug action is through irritation. This indicates a non-selective and often noxious or not pleasantable effect and is particularly applied to less specialized cells like epithelium or connective tissues. Mild irritations may stimulate the associated function. For example, bitters increases salivary and therefore gastric secretion. Counter irritants also increases the blood flow to the site, but strong irritation results in inflammation, corrosion, necrosis, and morphological damage. Fourth one is through replacement. This means the use of natural metabolites or hormones or their congeners in deficiency states. That is, using of levodopa in Parkinsonism, insulin in diabetes mellitus, iron in case of anemia. Next one is cytotoxic action. Selective cytotoxic action of certain drugs is utilized for cure or palliation of infections and neoplasm. Examples: penicillin, chloroquine, sidovudine, cyclophosphamide, etc. Next, let us see the mechanism of drug action. A drug may act as a result of its physical properties, which include physical mass, taste, radioactivity, radioopacity. First is physical mass. Compounds like agar and psyllium seeds absorb water when administered orally and swell in size. That is, their physical mass increases. So this irritates the peristalsis process and exerts a laxative effect. Next one is taste. Compounds with a bitter taste increases the flow of hydrochloric acid in stomach and therefore improves the appetite. These substances are called bitters, for example, chirata. Next is radioactivity. Example, iodine in the treatment of hyperthyroidism. And the other property is radio opacity. Here the examples are barium sulfate as barium meal and organic iodine compounds for the visualization of the urinary and biliary tracts. Next is chemical properties. In chemical properties, we make use of the acidity or alkalinity and also the chelation properties. Acidity or alkalinity, example, antacids, that is neutralization of gastric hydrochloric acid in the treatment of peptic ulcer. Chelation, metals like lead and copper can be eliminated from the body with the help of substance called a chelating agent. These chelating agents form a ring-like structure with the molecule of the metal. This structure is non-toxic and water-soluble and is excreted in urine. Through enzymatic mechanism, drugs may act by either enzyme stimulation or enzymatic inhibition. Drugs are foreign substances, so enzyme stimulation by drugs are unusual. Drugs only increase or decrease the rate of enzymatically mediated reaction. Enzyme stimulation occurs commonly with endogenous substances such as hormones. For example, adrenaline stimulates adenyl cyclase. Stimulation of enzyme increases its affinity for substrate, so the rate constant of the reaction is low. Increase in enzyme activity can also occur by enzyme induction, that is, synthesis of more enzyme protein. Next one is enzyme inhibition. Inhibition of enzyme is a common mode of drug action. It is of two types, that is non-specific and specific. The specific is again classified into two, that is competitive and non-competitive. Competitive inhibition can again be classified into equilibrium type and the non-equilibrium type. Next, let us see what is a non-specific inhibition. Non-specific inhibition. Drugs or chemicals causes denaturation of protein. They alter the tertiary structure of any enzyme with which they come in contact and thus inhibit it. For example, strong acids and alkalis, heavy metal salts, phenol, etc. inhibit enzymes non-specifically. Such inhibitors are too damaging to be used systematically. Next one is specific inhibition. Many drugs inhibit a particular enzyme without affecting the other. Such inhibition is either competitive or non-competitive. Competitive equilibrium type inhibition. Here, the drug, being structurally similar, competes with the normal substrate for the catalytic binding site of the enzyme. So the product is not formed or non-functional product is formed. Such inhibitors increase the Km, but the Vmax remains unchanged. For example, physostigmine and neostigmine compete with acetylcholine for choline esterase. Captopril competes with angiotensin 1 for angiotensin converting enzyme. The figure is shown here. Instead of the substrate binding to the binding site of the enzyme, it is the inhibitor that has binded and thus no product is formed. Next one is non-equilibrium type. Here the drug causes enzyme inhibition by forming strong covalent bonds with the enzyme, or they have such a high affinity for the enzyme that the normal substrate is not able to displace the inhibitor. In this situation, Km is increased and Vmax is produced. For example, organophosphates react covalently with the esteric site of the enzyme, called esterases. Next one is non-competitive inhibition. As the name suggests, here the inhibitor reacts with an adjacent site and not with the catalytic site, but it alters the enzyme in such a way that it loses its catalytic property. Here the Km is unchanged but Vmax is reduced. Non-competitive inhibitor and the corresponding enzyme is given as an example. Aspirin and indomethacin, the enzyme is cyclooxygenase. For acetozolamide, it is carbonic anhydrase, and finally for omeprazole, it is H plus K plus ATPase. And the figure shows the non-competitive inhibition, where no product is formed. The next one is through receptors, which we'll see in the next video. Thank you.